Okay, so in the first question of our assignment, we like to we're given that the xt is it's a wide-side stationary stochastic processes with the autocorrelation function of r and the spectrum density of s, and we like to first prove that the autocorrelation function is real and even. We could do this concurrently. We just take the definition of the autocorrelation function, and we're for the second inequality we plug the condition where where xt is a real stochastic processes, so xt must equal to its conjugate. So expectation must equal to the conjugate of this expectation. So we get that the autocorrelation function is real, and the second it happens to equals to the definition of the autocorrelation function of in this form. So xt tau must equal to the xt minus tau. So xt must also be even. And then we have proved that Rx it's real. As for the second question, we like to prove that the spectral density must be a non-negative one. We know that if this is an autocorrelation, if any autocorrelation function has the following property for any ti and tj, and for any for any deterministic function, we have this series. The summation of series is non-negative. So we may as well take the deterministic function as the form of the e to the j ti, and its complex conjugate is e to the minus j tj. So we have this. So and we multiply by this 1 over n at the end. So it must also be a non-negative one because n is a positive integer, and we take that sounds like taking the average of these n terms. However, if we choose these ti and tj in the following way, ti equals to a plus b minus a I over n over I, and tj equals to n plus b minus a n over I plus 1, we could get that this actually, if we take the limit of n to infinity, the left side of this equality, it's a definite integral with the upper limit of b and lower limit of a, and according to the properties that the sign of the limit is kept in the sequences, we can get that the definite integral is a non-negative one. So we also use the properties of keeping the sign of the sequences again. Take the limit of a to the infinity and take the limit of b to minus infinity. We get that's infinite integral. It's non-negative. That is the form of this. That is this x omega is a non-negative function.